All right, you guys, welcome to what I'm hoping is going to be our last video on our exponential function unit. Okay. Um, I'm going to have this up on a different screen that's not going to be visible to you, but I have put a PDF version of this table in your Canvas assignment that I highly recommend that you either print out or you have available to you because it's going to help you get started. Okay, it's not complete. Okay, this is not a complete powers table, but it's got enough. Okay, I think to get you going and to kind of help familiarize you with some values. All right, so first things first, let's make sure you understand how to read the table, and I'm going to move this off to my side to my screen. Okay, and we're going to look at solving some problems. Okay, um, number one, okay, when I take one and I square it, or 1 to the third power, I always get 1. So that's really a boring row. But let's just make sure, let's look at 2. Okay, so remember 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16, 2 to the fifth power is 32. Okay, so that's how I'm going to utilize this table. Okay, is I'm going to be looking for values here, and then over here is going to tell me what my base is, and then the numbers are going across the top are going to give me my exponents. Okay, all right, so let's go away from here. Okay, and I will reference that. Okay, for myself on a different screen. All right, so let's look at our equations that we've got here. Okay, so it says I need to solve for x. So I have 7,776 with an exponent of x plus 1 equals 216x to the minus 5. Okay, so we've done lots of different exponential equations and we've used our calculator for some. Okay, and then we have taken the logarithms of both sides. There's lots of different ways that we can solve problems. Okay, here is an additional approach. Okay, and it's different. Okay, so I need to take 7,776 and 216, and I need to change them to have the same base. So in terms of their exponent, so in terms of the value here, the base, okay, and then I have a value in the exponent, I need that base to be identical. Okay, the exponent can be different, but I need the base to be identical. Okay, because when that happens, I'm allowed to do something to help myself solve. Okay, all right, so if I have 7,776, okay, I'm going to go over here and look at my table and hopefully and pray that it's there. Okay, and it is 700. I can see it. Okay, it's in the row of 6 to the fifth power. Okay, so I'm going to rewrite that as 6 to the fifth power. I'm going to put it in parentheses, x plus 1. Okay, all right, and then 216. So I want to stay in that row. I'm going to go across, okay, and 216 is there, and it's going to be 6 to the third power. Okay, now all the problems that you're going to be solving today have a common base. Okay, so you absolutely can find one. So if you don't find one, you need to keep looking. Okay, because the whole point of this exercise, if you look up here in Delta Math, is that they're going to have a common base. Okay, because we want to focus on the next steps. Okay, all right, and what are those next steps? Well, now what I'm going to do is I'm going to use my exponent rules. Okay, my exponent rules from Math 1 say that I'm allowed to multiply these exponents. Okay, and because of the way they're written, it's actually going to be the distributive property. All right, so 6 to the 5x plus 5 equals 6 to the 3x minus 15. Okay, when you get to this point, okay, I can literally just cancel the sixes out. But this is why I'm doing this, okay? If I take the log of base 6, okay, the log of base 6, okay, that cancels and it leaves me my exponent, okay? But what happens is that we start to skip this step. So if I were to take the log base 6 of 6 to the 5x plus 5 equals log base 6 of 6 to the 3x minus 15. Okay, well that cancels. Okay, but what happens is that over the years, we all just, as mathematicians, we just skip it. And we just say, hey, same bases, I skip it, and I know now that 5x plus 5 equals 3x minus 15. Okay, now up until that point, okay, that's all the new material. This is now old material. You know how to solve an equation. Okay, so this is the new part. Okay, all right, so now to solve, you have choices. I'm going to subtract 3x. So I get 2x plus 5 equals negative 15. I'm going to subtract 5. So I get 2x equals negative 20. I'm going to divide by 2. So x equals negative 10. Okay, and then I'm going to go over here. Remember, we don't have to type in x equals. I'm going to type negative 10, submit my answer, yes. Okay, all right. And you can see here, even in Delta Math, you can see he skips over that entirely, okay? Because that's just what we know, okay? We know that once we have a common base, they cancel out, and I set the exponents equal to each other and I solve, okay? All right, so let's try one more and I'll come back in another video. All right, so 16 to the x minus 4 equals 256 to the 3x plus 3. Okay? All right, now, as long as you have a common base, okay, you're fine. Okay? Now, if you look on your chart, okay, you have 4, base 4, okay, you have 16, and you have 256. Okay? So that means 4 to the second power to the x minus 4 equals 4 to the fourth power to the 3x plus 3. Okay? Now, if you're sitting there wondering and you're like, wait a minute, I know that 2 to the fourth power is 16, and that 2, okay, you know that 256 can be rewritten, okay? I'm trying to think what it is. 2 to the 6th? Nope, 2 to the 8th. There it is. Okay? I could have written it using 2. So I could have said 2 to the 4th, x minus 4, 2 to the 8th, 3x plus 3. Okay? Those two steps, they are equal. Okay? So there's actually more than one way to approach this problem. Okay? My goal is that you have the same base. Okay? Does this number and this number match? Does this number and this number match? As long as they do and you've done everything mathematically correct, you're good. Okay, so I'm going to stick with this problem right here. Okay, you're welcome to try that one if you just want to say, hey, let's see if she gets the same answer. Okay, I'm going to multiply my exponents, which means I have to distribute. So 4 to the 2x minus 8 equals 4, and you want to do this step first, to the 12x plus 12. Okay, the 4's cancel, so my exponents are going to be equal to each other. Okay, so I'm going to subtract 12. You could have subtracted 2. So negative 10x minus 8 equals 12. I'm going to add 8 to both sides. So I get negative 10x equals 20. Divide by negative 10. So x equals negative 2. Okay? And I just go over here, type in negative 2, submit my answer. Yes. Okay? All right. Good luck. I will come back in the next video to help you with your next set of problems.